I'm following the sequence. Otherwise, not we will put. And this is A1, D1, then A2, D2. This is S0, carry out. It's out. I'm following a scenario. There is sum 1, carry out. Sum 2, carry out. Now, if you see the board, they are all independent. Is that correct or not?
Yes, ma'am.
Yes. Now, I want to make it dependent. That means I am wanted to do first a addition, and if at all it has a carry, I have to propagate it to the next one. Now carefully understand. I want to propagate, for example, if I get this, I want to attach this here. Okay, now think if I in blue I will write. I'm so sorry. If at all I will add what happened? I'm in class. Okay. Okay, you need the permission to the campus. Okay, fine. I will. Can I call you after something because I'm in the class? Illegal. Okay. Okay. Right. So now, sorry, I'm so sorry. So if at all I have a carry and I want to feed it here. Now hold on. According to the rules of half adder is a block which can take only 2 inputs at a time. Is that correct? And gives 2 outputs. Did we study that or not?
Yes, ma'am.
I need a response.
Yes, ma'am. Yes, ma'am.
Right. So now in our sequence, if at all I want to pursue this one over here, half adder block won't suffice. You agree for that?
Yes, ma'am.
Yes, ma'am.
So now, whenever I want a carry to be propagated and to the next one and make this one sequence, I need to have where this carry is acting as a third bit and a full adder has the capacity to add 3 bits. Do you agree?
Yes, ma'am.
Yes, ma'am.
Yes,
So
ma'am.
now this one I will take it here and okay. And instead of half adder, I can take a full adder. Right? So now next another full adder. So A3, B3 thing and its carry can take here and then I will have a sum 3 and a carry 3 and this can go on. Now you see the sequence. Now you see the sequence. Right? So all full adders together are trying to work. Right? And because this one is the odd man out, can I also take a chance of keeping this? Because initially carry is not there. I will take C0 is a carry which is 0 all the time. Full adder. The last one also has a full adder. And now if you see a combination is going on. That means initially I will feed 3 inputs where this one is the C carry. Starting carry is 0. Right? And then it's some okay, and this output carry. Okay, this is okay. Start. You can take start. Okay, starting carry, and this one is the carry generated from here. That will take it here. Is that fine?
Yes, ma'am.
Right. So now, what do you think? Like this type of addition can be performed here using this sequence? Is there any other class going on? Please mute. Okay. Right. Now, did you understand here? You understood, right?
Yes, ma'am.
Yes, ma'am.
Okay. Now hold on. Now, if this such type of facility is available, now I can visualize an IC, right? Where we have a bulk of full adders interconnected. Okay, already interconnected. We did not do the connection, and we have only the facility to connect their sums because carry is again interconnected. Na? Carry is interconnected. So I have the capacity to collect only the summations right? And towards the end, I will get one extra. If at all IC is varying 4 full adders, I can collect the last sum, so last carry and all the sums. Is that correct?
Yes, ma'am.
Yes, ma'am.
Right. Now, what do you think? How it will work? Like, do you think that all the full adders will be working at the same time? Now, for you, a simple question, because you people are smart enough. My inputs are ready. Why? Because I know what inputs to be provided. Right? Will I get the sum at the same instant? Again, I'll repeat my question. My inputs are ready. A, like this is A0, A1, A2, A3. Ready. B0, B1, B2, B3, everything is ready. Okay. I will switch on all that manually at the same instant. Will I get the sums at the same instant?
No, ma'am.
Why?
No, ma'am.
Ma'am, because carry is dependent on the less.
Yes. Now, can I say that every carry, right, in order to make this full adder work, it has to wait for some time for this carry to be generated.
Yes, ma'am.
Correct? Similarly, in order to work this one, it has to wait till this carry is generated. So, you can expect a delay in our outputs, right?
Right, ma'am.
So now we have no option rather than waiting. So this type of adder, though we have a sequential or a sequence of full adders, then also we are not able to collect the summation at the same time. You agree for that?
Agree, ma'am.
So this one is the initial design, but you have to understand whenever we want to have a thought process, we have to understand what is the initial design. This was the initial design. How do you think that we can fasten or quicken this process? What manner I can do this process a bit quick? Do you have any ideas? At this level, it is only this much. Because I want to add 4 bits parallelly, though it is a parallel adder, I am not getting the parallel summation at the same instant. Again and again, I am trying to repeat. Please try to understand. Parallel adder is there, okay, but I am not able to get a parallel result. You agree that, right?
Yes, ma'am.
Right. So only flaw, nicely observed, because the carry became dependent. The third bit, which is acting as one of the input to the full adder, is becoming dependent on the previous one. Is there something wrong? Is that correct? So we are fine with this now?
Yes, ma'am.
We have a sequence now. We can have a binary parallel adder, but there is some flaws with that. Okay, so this was the initial design. There is still hopes for us to improvise. Okay, so maybe you only will give me the way also, right? There are other adders also, but as of now, this is called binary parallel adder. Add. Yes, parallelly it is adding, but I will not get the parallel result. There will be a delay. That's right. Okay, can I increase this one for 10 bits also? Because A0 to A9, can I add?
Yes, ma'am.
Right? So how many full adders are required?
N-1.
That's it. So we require that many full adders, and then the sequence goes on and on and on like that. Okay, so this was also a combinational circuit. Now if you see, we may have a combinational circuit. Can we tell it is a combinational? Is there any memory here? There is no memory, neither feedback. It is only interdependency is there. Correct?
Yes, ma'am.
Right. So this is one of the combinational circuit. Okay. So now let's start doing one small question. Right. So if you have a pen and paper with you, can you just note down this? Okay. So there is Design a combinational circuit with three inputs X, Y, and Z. Okay, now carefully understand. Design a combinational circuit with three inputs X, Y, and Z and three outputs A, B, and C. Okay, clearly mentioned. They have told to design with three inputs X, Y, Z, three outputs A, B, C. And now the constraints start. When the binary input is 0, 1, 2, or 3, okay, 0, 1, 2, or 3, the binary output is 1 greater than the input. When the binary input is 4, 5, 6, or 7, the binary output is 2 less than the input. Very nice question. I will write. So it's an example problem or sorry, textbook problem. Inputs are X, Y, and Z, it seems. Okay, this is inputs and outputs are A, B, and C. Okay, now what did they say is if inputs are 0, 1, 2, or 3, okay, output will be, what did I say? 2?
1 greater than the input.
1 greater than the input. Okay. 1 greater than the input. Okay. Now let's decode this. This is first statement. Second statement is 4, 5, 6, or 7.
2 less
Right?
than input.
Output will be 2 less than input. These two we have to follow. These are step 1 and this is step 2. These two we have to follow and frame the combinational circuit. But input and output numbers and variables, everything are ready with us, right? Because they have mentioned. Right. So how we are going to do this? So we will, as usual, create a. Those who have done, you can post it, no problem. So we will have 0, 1, 2, 3. Okay, first we will finish this. Right, if it is 0, the output should be 1 greater than this. 0 plus 1, it will be 1.
When x is equals to 0, for that the output should be greater than 1, and for x is equals to 1, the output should be less than 2 less than input.
No. Is that the question?
No, ma'am. I am telling because when we do the binary, the x only the x thing is changing for two inputs.
Not 2 inputs, it's 3 inputs, X, Y, and Z. Na? Clearly 3 inputs.
Ma'am, decode that. You will get what I am saying.
Oh, okay. 3 minus 1, 2. Okay, 0, 1. Acha, you are telling this everything in crisp. That's what, na? This is what I can understand.
Ma'am, draw second one also for 4, 5, 6.
Yeah, we will do that. Till 4, 5.
We can
Till
do
0. Yeah.
we can do like
4, 2
4, 5,
less
6.
than the input. 2 less than this input means it will be 2, 5. 6. 7 will be this. This is what? This is step 1 till here. This is what the first constraint. If the inputs are this one is 2 less than the input. Now, how complicated you have decoded? See, this 4 terms is the first constraint. Whenever the input is 0, 1, 2, 3, you have to make 1 less than that. So 0, 1 less than, sorry, 1 greater than that. So 1 greater than that, 0 plus 1, it will be 1. So this 1 plus 1, it is 2. So 2 plus 1, it is 3. 3 plus 1, it is 4. Is that correct?
Yes, ma'am.
So now your job is to find out A equal to, B equal to, C equal to in terms of your XYZs. Right? Boolean expression.
Yes,
And
ma'am.
give the combination circuit. Yeah. Somebody has told so complicated, I don't understand. You can use the min terms or max terms. Always don't use the min terms only. Get the reduced expression, and if you are done, please post. The expression also. Where's the circuit? Vidya, where is the circuit?
Yes, ma'am. Doing.
So try to do the universal gates.
Ma'am,
Yes, post it. What happened? Questions? I mean, you have
we have
doubt?
we have post only the reduced simplified formula or logic diagrams also.
You have to draw the logic diagram. Just giving the expression doesn't work. You have to do the logic diagram because the black box has to be designed now finally.
Yes, ma'am.
Finally, the black box has to be designed now. Yes, Swaru. Expression is fine. Where is my logic circuit? That box.
Okay, ma'am.
Expressions are good. Divya also has given me. Girls, nothing you are doing. Oh my God. Sujinder, Sulagna. Sulagna, is that correct? Yes, ma. Sulagna. Sulagna. My God, so much. Reduction is not possible, ma.
No, ma'am. The reduced expression is that A is equals to x square plus yz.
Oh, A is easy only. Seems to be pretty tough. Samaikar, what happened? Let me see the design. Huh? What about B and C? Only A you have done. What about B and C? All together in the black box.
Ma'am,
So
together in a black box, it will become a bit confusing. Can we draw separately?
see, actually, you have to mimic how a combinational circuit looks. It is confusing only because none of you people are giving the outputs at all. I don't know in basic electronics how you practice. You have to always give the outputs. Komalika, expression is cool. Where is the diagram?
I'm doing.
Yeah. This is it. No, things are there like it's tough only. I'm not saying that it is very easy. It's very big, no? Suchira.
Ma'am, it can be done using 5 gates.
Oh, you can do all the things in 5 gates, all the
Yes,
four.
ma'am.
I mean, A, B, and C.
Yes, ma'am. I think so.
Wow, it's good. If it is done, if it can be done, means it's good. Because I'm not showing so much. Oh, I messed up.
Ma'am, only using universal gates or we can use and OR gate?
Anything, but I want the circuit to be very small. Aha, good. Expression is good. Circuit if it will try to design.
Ma'am, I have sent it above.
Who is speaking, huh?
Ma'am, Ahan, ma'am. I have sent it.
Yeah. What did you do? You have sent it?
Yes, ma'am. I've sent the circuit.
Prior? Or you are sending it? Like you get loaded.
Ma'am, sent it above. And I can send again.
Yeah. I'll just check out. I think I didn't receive. Yeah, you please send it again. BG. Yeah, ABC. Pretty big. Yeah. Oh, used exclusive ORs, right? That's what ABC is very good. You can see, actually, I think everybody can see the postings, right? Everybody can see or no?
Yes, ma'am. Everyone can see.
Okay, then you can just check out Ahan's posting. He kept it cool.
Yes, ma'am. Check.
I don't know how correct it is. You can cross verify. Even if you don't know, we can be good in commenting, right? We use exclusive ORs. Yeah, that's another one. Because since I didn't keep any mandatory things that you use only these gates, you can use any gates. Wait, let me share. Yeah, you people can check out. This is Ahan has sent. Thank you, Ahan. But you please verify. Always, and another small suggestion here. Please write the outputs of every gate. It makes it very easy, right? And you can calculate and check out also. Cross verify. Is that correct, Ahan?
Yes, ma'am. Yes, ma'am. I did it in a
Every
hurry.
gate output you try to write. Okay, everyone can see. Aishwarya has sent something. Discussing is loading, no? We are pretty slow here. And then Aditi has sent. So Aditi also has used a pretty number of gates, but she is using only basic gates, I guess. Yeah. Then Priya also has used good. At least something you people are at least good. Yeah, good. Okay, you tried, but you can cross verify Hans. Okay, whether that is coming or not. Right. So now I got one interesting problem here. Okay, let's start working on this one. Okay, I'll share the screen. Okay, it's some downloaded one, but I'm much interested to work on this. Okay, should I share the screen?
Yes, ma'am.
Okay, just a second, just a second. It's okay. Now you just concentrate on 4.6. Okay, it's a practical problem. Now, since we claim ourselves to be experts of combinational designs. Okay, now let's see. These fellows are working now only. Oh, so sorry, man. There's a lot of disturbance going on. Okay, a manufacturing plant 4.6 only. Please concentrate on this. A manufacturing plant needs to have a horn sound. Okay, to signal quitting time. Just concentrate on 4.6. I will go outside and bash this bugger center. Yes, I'm back. Yes. You people have studied? Oh my god, I have a lot of disturbances. Natural disturbances, artificial disturbances, everything. Okay. Now 4.6, are you able to see?
Yes, ma'am.
Okay. A manufacturing plant needs to have a horn sound, it seems. Right? The horn should be activated when either of the following condition is met. Right? First condition is it's after 5 o'clock and all machines are shut down. And second condition is it's Friday, the production run of the day is complete and all the machines are shut down. Design a logic circuit that will control the horn. There's a hint also. So what do you say? What do you think? How we are going to design such type of problem? It's a practical problem, industrial problem. Right now we are engineers. Any suggestions?
Ma'am, we can have four variables, like one for if it is 5 o'clock or not, another if it is Friday or not, another one all machines are shut or not, and the fourth one about production is run for the day is complete or not.
Okay. So all the four. Okay. Right. In that case, we will take the output alarm is how many? I don't know. Shweta has told. Who is
Yes, ma'am.
speaking?
Yes, ma'am.
Shweta. Yeah, Shweta. So what about the output?
Only one output.
So alarm thing, sounding. That's what I activated.
Yes, ma'am.
Okay. So in this situation, every day after 5 o'clock it will sound, na? Every day after 5 o'clock and machines. It has to sound.
A case might intersect when
Yes.
when
it's 5 o'clock and it's a Friday also. So that case might intersect.
That's all. That's all. We should have some more, I don't know, thought process that is required because this is a little vague problem. It is 5 o'clock and Friday. So, and then the machines shut down. 5 o'clock, production is complete. All one. Then also it should be activated. That's what, no? See, I think another case is there when even if it is not Friday, 5 o'clock and machines are shut down. That also has to be activated. Because the horn should be activated when either of the following condition, either that or this.
Yes, ma'am.
Correct. So now, what do you think? So let's hit the board. So what I am supposed to do? We have 4 inputs. Already heat is provided and Shweta has elaborated also. Thank you, Shweta. So we have output is 1. Right, output is 1. Yes, something was suggested. Output is on. That is fixed. Right? So input conditions are production 5 o'clock. Then what else? System shutdown.
Machine
Friday.
shut down and production complete. And production complete.
Yeah. So I can give some A, B, C, D to this. Afterwards, we can elaborate also when we are discussing the problem. That is fine. So what did they say is it has to be activated. That means active means 1. That's what we will fix. And inactive means low. Right. So now, if it's Friday and the systems are shut down and it is 5 o'clock, production is there, it has to be activated. That is one thing what I can find it. Another one clearly it has been given. What is that? If it is
Either of. Ma'am,
5
it is 5
o'clock
o'clock and shut down. Machine
and
shut
shut
down.
down,
Yes.
then also. That means these are anything. Or this has to be compulsory 0.
No, ma'am, anything.
Ma'am, it is anything. I
If
don't
it is
care.
anything, yes. If it is
Then don't
anything, yes. I have an option like this. See, that's what I'm trying to decode. So from the given thing, this is what I understood. So if particularly this particular one, if I elaborate, I will have an option like this, which is already there. I have an option like this. I can have an option like this. Oh, this is already. I have 2 options, no? This can take 0, 1. This can take 0, 1.
Ma'am, 0, 0.
Zero zero both.
Yes, that's what. That is there. Then what else? 1, 1.
This much.
One is done.
So this particular stuff, I don't know how many are concentrating. This one can be decoded into 3 forms, right? Another one is already there. All these levels, the output should be 1. Correct?
Yes, ma'am.
Yes, ma'am.
Right?
Yes, ma'am.
Other than this, I have combinations like, I might get combinations like this, which is
0.
no horn, right? I will get like this combination also, which is no horn. So rest of the things you can just completely fill up, right? Other than this stuff, 1, 2, 3, 4, the decoding of that particular lines, remaining all will be, horn won't be sounded, like horn won't be activated. Is that correct? Any other say? Right, there are 100+ students, only one is talking.
Ma'am, show the question only.
Again, one more time. Yes, yes. Sure. I'll share the question. You can take a screenshot also. Just I try to download. Yes.
Ma'am,
Four
the
point.
horn should be activated when either of the conditions is met.
That is what. That is what. That's what we have to do some brainstorming. It's not necessary I have concluded one. First, initial things I have kept. Okay, initial active and inactive, high and low I have suggested. Then afterwards, the first one is after 5 o'clock and all machines are shut down.
Ma'am, it should be 1 for the condition 1011 also, ma'am.
1011. Who is
Yes,
it?
Yes, ma'am. 101.
Elaborate how it will be 1011.
because in the second condition it's mentioned that if it's Friday and the production run is complete and all machines are shut down, then
So,
the 5 o'clock condition.
Yes, ma'am. In
why?
one condition,
Yes,
Friday.
ma'am.
5 o'clock is don't care,
5 o'clock is don't care, and other
and the
three are
rest all
one.
are one.
Rest are one. Then it will horn will be activated.
Yes,
Okay,
ma'am.
let's see that. 5 o'clock is a don't care and rest are all one. So then also it is high. Correct?
101.
So
Yes,
another one is
ma'am.
1011 condition also is high. Yeah, good.
Ma'am, what is there
Ma'am,
for C?
so
Hmm.
C,
What
C.
is the answer? Huh? Who is asking that?
Ma'am, I am asking that what is written for C below C?
shut down.
Shut down, shut down, shut down,
Okay, okay.
shut down, shut down. Huh. Right, right. Yes, ma'am. I agree completely. Any more? Some more thoughts?
No, ma'am,
Yes,
this much.
ma'am. For the 0101 it should also be 1.
0101. So 0101 means
5
production
o'clock and all machines are shut down.
production and all machines are shut down.
No,
That I
it is
already
01.
0101 I already done. See, it's after 5 o'clock and all machines are shut down. So 0110.
Yes, ma'am.
That is first one I have already taken. Zero, I mean, don't care, 11, don't care. So that if I elaborate, then only it has come, no?
Okay, ma'am. Oh, sorry.
Yeah, we have already done that. We have already done that. So some more thought process.
Ma'am, this much only.
This much only. So
Ma'am,
now,
in the first expression, if we take that 5 o'clock don't care, then it will be 1.
no, just a second, just a second, just a second. So finally, let me concise it. Yes. Class. Just another 10 minutes. These fellows are not leaving now. So. Yes, in concise. Production shut down. I mean, production completed 5 o'clock, shut down, and Friday. Okay, then the horn is activated. I think these are the three things which we can grasp from the two constraints. Like afterwards, don't care, you fill it up later. That is fine. Okay. Any more things are there?
Ma'am, this first condition 111,
The part of this also.
Yes, ma'am. It is a part of that one, third
Yeah.
condition.
So I will remove that. Yes, it's good. Better. Right afterwards, you elaborate it. Because wherever don't care is there, you have the option to fill either 0 or 1. So that time each one will be again having some more. Right. Here I'll put 0, 0, 0 combination, 0, 1 combination, 1, 0 combination, and 0, 1. You will get 4 terms. See, can I produce from here like this one? From this one, I can get 4 combinations. from this.
Yes, ma'am.
Yes,
Correct?
ma'am.
So all will be 1. Right, from this one, this all have been evolved. Right. Similarly, from this one, I can have evolution of from this one. I mean, from this particular set. Okay, you will have 1 0 1 1, which is supposed to be 1, and 1 1 1 1, which is supposed to be 1. So rest of all the things will be 0. So your alarm system is fine. See, this is just an industrial exercise we are trying to work out, a practical solution we are trying to provide, because they have given a constraint that after 5 o'clock the horn should be activated. So I think almost we have completed. Is that correct? Any more people? 111 people are there, 101 people are existing. Why few inputs are coming for me?
Ma'am, 1111 is already done. Twice we have written.
111 is already done. Yes, it's very good. See, I'm just telling the sharing that from each one how many are coming. So afterwards, when you write the full truth table, I mean full truth table, 2 times why to repeat, you can take only 1. Correct?
Yes, ma'am.
Yeah. 108 students are there existing. Only very few inputs are coming. Some more thought process. Interesting, right? So let's see. There is another one. Okay, I like this particular one. Yes, we can continue that one. Now, if you see problem D, let me share this. There is another question. Yeah. 4.848. Just see the circuit. It is having some logic circuit you have to design. Right? For an automobile alarm circuit used to detect certain undesirable conditions, the 3 switches are used blah 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 to indicate something. Okay. Right? Then afterwards, should I post it?
Yes, ma'am.
Yeah, I will crop it and post it. Right? It's an interesting problem. You can just work out. The other one also, both of that you can do it. I'll post it right now. Like you should be having some other class. So I will cut that and post it. Then afterwards try to work out. I want the complete. Right. I want the complete solution. Solution in the sense what? I need a circuit. Just not the truth table like this. What I have discussed. I need the circuit. Right? Did you understand? Like how to decode the constraint given and then afterwards assign the truth table. See, in this 0, 0, 0, 0 condition, nothing is there. Horn should not be activated. See, you can design the circuit other way around also. Activated is 0 and inactive is 1. That also you can design, no problem. But you have to at least mention what is your genesis is, like what you are following. Okay?
Okay, ma'am.
Right? Okay, I'll post this problem also and the other problem also. If you have the solution with you, please try to give me night itself. Right? And tomorrow, Shweta, my class will be 11 o'clock, right?
Yes, ma'am. 11 o'clock.
Okay, you should be having another class?
Yes, ma'am.
Yes.
Okay, fine. I will post you. Right, thank you.